You have the most powerful computer in the known universe sitting right between your ears. But what if I told you it can be totally fooled by a simple picture? Today, we are diving deep into the bizarre and fascinating world of optical illusions to figure out exactly why. Let's get into it. Okay, let's start with this. Just take a look at the image on your screen. What do you see? If you're like pretty much everyone else, it looks like those shapes are slowly, kind of creepily rotating, maybe even pulsing a little. Just keep your eyes on it. But is it actually moving? And the answer is no, not at all. This image is 100% static, not a single pixel is moving or changing. So what on earth is going on? You just got your first taste of a powerful illusion, a moment where what you see and what's actually real are two completely different things. So how does this even happen? In this first part, we're going to explore the deception your own eyes play on you, and we're going to uncover a really surprising truth. This isn't a flaw in your brain's programming. It's actually a feature. First up, let's look at how our brains get tricked by two of the most basic things in the visual world, color and size. And you'll see it all comes down to one single crucial idea, context. All right, let's start with the color illusion. Take a look at the two gray squares here. The one on the left seems way lighter than the one on the right, doesn't it? Well, what if I told you they are the exact same shade of gray? So why does this happen? This is what's so cool. Your brain is basically a comparison machine. It never ever sees a color in a vacuum. It's constantly judging that gray by comparing it to the colors right next to it. So against a dark background, it pops and looks lighter. Against the light background, it looks darker. It's all relative. Okay, so that's color. Now let's see how the exact same principle of context applies to size, with one of the most famous and honestly mind-bending illusions out there, the Ames room. This is a place where two people of the exact same height can look like a giant and a dwarf, just depending on where they stand. So how does this amazing trick work? The secret is all in how the room is built. See, it's not a square room like you think it is. It's actually a trapezoid. The floor slopes up, and one corner is way farther away from you than the other. But because your brain has spent your entire life seeing normal rectangular rooms, it makes a powerful assumption. And that single false assumption completely shatters your perception of size. So you see the connection, right? Both of these incredible illusions work for the exact same reason. Your brain is desperately trying to make sense of the world by using context. For the color illusion, the context is the surrounding shades. For the Ames room, the context is the surrounding room. And in both cases, that context leads your brain astray. All right, now let's switch gears a bit. Let's talk about how our brain's obsession with seeing a 3D world creates some seriously weird illusions, even on a flat 2D surface. Our brains are so determined to find depth that they sometimes invent it, creating shapes that are literally impossible. I mean, just look at something like the Penrose triangle or one of those impossible staircases. You can see it, right? Your brain instantly interprets it as a solid, three-dimensional object. But the moment you try to actually imagine building one, you realize it completely defies the laws of physics. And this is a perfect example of how our brains are wired. We are programmed to take 2D clues, lines, shading, perspective, and immediately try to build a 3D model in our minds. Each individual corner of that shape makes perfect sense. But when your brain tries to zoom out and put it all together into one object, bam, you get a paradox it just can't solve. Okay, here's another 3D puzzle that probably messes with you every single day. A mirror. We all say it, right? A mirror flips left and right. You raise your right hand, your reflection raises its left. But why doesn't it flip you up and down? What's going on there? Well, the secret is, mirrors don't actually reverse left and right at all. They reverse front to back. Your reflection is a perfect copy of you, just depth inverted, like it's been pushed through the mirror. Your brain sees this and interprets it as another person standing in front of you. And, well, from that point of view, their right hand is opposite your right hand. It's not a flip, it's a whole different perspective. All right, for our final category, let's look at illusions that are born from a very simple limitation of the human brain. You just can't pay attention to everything at once. This constant battle for focus is what creates some of the most compelling illusions of all. You've definitely seen an image like this before. Look closely. What do you see? Do you see a young woman kind of looking away over her shoulder? Or do you see the profile of an old woman? You can probably see both, but here's the real test. Can you see them at the exact same time? Go ahead, try it. It's impossible, right? The very second your brain decides to focus on the lines that make up the young lady's jawline and necklace, poof, the old woman's nose and mouth just vanish into the background. And the moment you find the old woman, the young one is gone. Your perception here has nothing to do with the image and everything to do with where your brain decides to shine its spotlight of focus. And this brings us right back to where we started, that moving picture. Now that we have all these clues about how the brain works, we can finally crack the case. Why in the world does a completely still image appear to be in constant motion? Well, here's the big reveal. The movement isn't on the screen. It's in you. The specific patterns and the high contrast colors in this image are designed to exploit the tiny, involuntary movements your eyes are making all the time. As your focus naturally jitters and scans across the image, those tiny movements trick the motion-detecting parts of your brain. You are literally creating the illusion yourself. So, after all this, after looking at context and 3D perception and the battle for focus, what's the final verdict? What is the truth about why our brains lie to us so easily? And this is the most important thing to remember. Optical illusions aren't a sign that your brain is broken or flawed. In fact, they're a sign that it's working brilliantly. These illusions are just the side effects of the incredible life-saving shortcuts your brain takes every single second. To survive in a complicated world, it has to make assumptions, compare things to their context, and focus its attention. Illusions are just those rare moments when we get to see those shortcuts in action. So, in the end, it really comes down to this. What you perceive as reality isn't a direct, high-definition recording of the world. It's an interpretation. It's a story that your brain constructs for you based on past experience, context, and focus. And yeah, most of the time, that story is incredibly accurate. But sometimes it gets things wrong in the most fascinating ways. And that leaves us with one last, pretty wild thought to chew on. If your perception can be so profoundly tricked by a simple arrangement of shapes and colors on a screen, it really makes you wonder, doesn't it? What else about your daily reality isn't quite what it seems?